Take that, please. Consider a fluid flowing through a pipe with constant diameter. Consider a fluid flowing through a pipe with constant diameter from point A to B. From point A to B as shown below. From point A to B as shown below. So please from here, if you want to, you can put a middle one here. The idea is that diameter is constant. Now listen to this, look up, look up. Let's now use one of our topics to explain something here. Take down please. From the equation of continuity, we have that for continuity, what was the idea? That the mass flowing in, the what there, control volume, and what there, the mass flowing in must what there, be balanced. And we said for continuity, mass flowing in equal to what there? Mass flowing out. So that means the mass flow rate. Mass flow rate was what there? M dot. Have it? Yeah. So it means that mass flow rate at point A, M dot at point A is equal to mass flow rate at point B. That's M dot and what there? Point B. So I have this case here. We looked at a relationship between mass flow rate and discharge. Abi? But what was the relationship? Mass flow rate is equal to what there? Density times what? Discharge. If I replace this one here, it means that for here it means that the discharge of A, point A, or the density at point A times what there? Discharge at point A is equal to the mass density at point B times what there? Discharge at point B. So we have this. Okay, so what next? Next up, but also in terms of area velocity, what's discharge? Q is equal to what there? A times U. So replace this one here. It means that mass density at point A, okay, times this one here, so this is AU, becomes the area of point A times velocity at point A is equal to mass density at point B times for this AU, area at point B times velocity from point B. I have this. So I have this. Check your diagram. It says constant what there? Check. Constant what there? Okay, so look up. Look up. Listen, I have 2 points. Listen up, please. I have 2 points in a pipe. And we're assuming that this pipe has a constant diameter. From this one here, we can make an inference. The inference is this, that if the diameter is constant, then the area is also what there? Constant. Right. So it means that the area at point A is equal to the area at point B. From here, for constant diameter, we have that the area at point A is equal to the area at point B. So what? So that means I can cancel out. Of course, AA now cancels AB. So hence, I now have that density at point A, U at point A, that's velocity at point A, is now equal to density at point B, velocity at point B. Alright, so we are here. So we are here. Now listen. Check your notes. When we did, what's it called? Continuity. Check. in continuity, listen up, what is continuity? We had the same stuff here, where we had row, I think, was it row 1? I think it was row 1. Row 1, A1, U1 is equal to row 2, A2, U2. Now, here's the difference. In this case here, if you check, what we considered was what? This is fluid mechanics. Fluid studies both gases and liquids. In this case here, I was considering a fluid. And if you can remember this stuff here, we're doing different pipes. Pipes like this, are they? Yeah, like this. What we say, they expand and contract. So in this case here, the area were changing. And hence, they were not the same. So they didn't cancel out. What cancelled out here, if you check your notes, was what there? The density. Why? We said density of what? What's it called? A liquid is what? Constant. So it cancels out. But in this case now, what is cancelling out is now what there? The A is there. Now the issue is this. For this case here, we cancel out density with the idea that density of the liquid is constant. For this one here, do I also cancel out density? Yes or no? Why? 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 That's it. That's it. See something. Density is equal to what there? Mass over what there? Volume. We know that mass is constant, so set to, no problem there. That means density to a high extent is determined by what there? Volume. Not just mass, but volume. Now we know that volume of a liquid is constant. I mean, of course, volume cannot be compressed. Excuse me. If I have this stuff here, and this stuff is filled up, I can't press it much. Why? It's a liquid. If I empty this, and I cover it so that there's what there? There's air inside this thing here. I can squeeze it as much as I like. That means I can compress the volume very well. Why? It means that for liquid, the volume, it can be compressed too, but the compression is what there? Small, it's negligible. But for gases, if this thing is empty and there's air inside here, I can fold it as much as I like. That means volume for what? Gases is what? Can be very much compressed. So hence, this one here does not cancel out. So that means this one here will not cancel out. Why? Idea of compressibility is gas. Are we together? Let me know, are we together? Yes, sir. Alright. So I have this stuff here. We are, take that please. If you want to, we are, yes. Yes, but this one is a gas. We are, when we do past question on this stuff came out last year and 2 years ago. When we do question on this, look at the question, it's always a gas. Okay? Helium gas, hydrogen gas, carbon dioxide, it's always a gas. Take that please. Where rho A is mass density at point A, UA is velocity at point A, rho B is mass density at point B, and UB is velocity at point B. So that's like, alright, please check out this stuff, please. Sample problem, please. Carbon dioxide passes point A in a 75mm diameter pipe at a velocity of 5 meters per second, full stop. The pressure at point A is 2 bar and the temperature is 20 degrees Celsius, full stop. At the point B, down the stream, the pressure is 1.4 bar and the temperature is 30 degrees Celsius, full stop. For a barometer reading of 1.03 bar, calculate the velocity at B and compare the flow at A and B. Take R as being equal to 287.851 kilogram Kelvin. Solution, please. First thing first, please. List out given parameters, please. And what's the first you have there? What's the first you have there? Diameter. Diameter is equal to how many there? 75 millimeters. Alright, next up it says at point A That they said what velocity there? 5 meters per second. Number 2, I'm given velocity at point A as being equal to 5 meters per second. And what's next there? The pressure at point A is 2 bar. Number 3, pressure at point A is equal to 2 bar. Okay, what next again? They said at point B down the stream, the pressure is 1.4 bar. So number 4, I'm given the pressure at point B being equal to 1.4 bar. Okay, and temperature 30 degrees Celsius. Okay, now there's 20 for point A. Check. We have temperature at point A as being equal to what there? 20 degrees Celsius. Okay. Number 6. Temperature at point B. What's your value? 30 degrees Celsius. Then again, hold on. Again, they said for a barometer reading of 1.03 bar. What's that? Alright. Now listen. There are types of pressures. There are types of pressures. But most importantly, P absolute pressure is equal to P atmospheric. That's atmospheric pressure plus P gauge. That's gauge pressure. What's P atmospheric? P atmospheric is simply atmospheric pressure. Atmospheric pressure is also called barometric pressure. So in quote, if they tell you that barometer reading is so and so value, that becomes from there your atmospheric pressure. So please take your place. That atmospheric pressure is also called barometric pressure. So it means that if they say, let me use the language there. If they say for a barometer reading, it becomes atmospheric pressure or barometric pressure. So P atmospheric is given as how many there? 1.03 bar. Okay. Calculate velocity at point A and point B. Calculate velocity at point. So upon what? At B, Abi? Yes. And compute the flow at. Listen there. And compare the flow. So look at it. Look up. So how do you solve this? Look up this. How do you solve this? I've said before you solve any question, do an analysis. Analyze the question. Right? Go to your sheet there. Right? Try to see what do I need, what's not there. It gives you an idea of how to start it up. I'm asked to find velocity at point B. For this question, here's what I know. I know that rho A, AA, UA is equal to rho B, AB, UB. In fact, from here, I know that I don't have to bother about this and this because it's a constant diameter. See the difference between this question and what we did last time. In last one, we were giving you different diameters. Are they? Yes. They say it increases to this, and they give you different diameters. In this one, they give you just one diameter because it's what there is constant. So what does it mean? It means I don't even have to stress myself to find area. It's not important. If you have the time, you can do it, but it's not important. So it will work. I'm now left with density at point A, U at point A, equal to density at point B, U at point B. What do I have? What do I not have? I'm asked to find velocity at point B. That's this. Do I have this one here? Yes, I have this. Do I have density at point A? Yes. Density at point A? Yes. Do I have it? No. Can I find it? Yes. Yes. How? Rho is equal to what there? P all over what there? R root T. That's what the mind said. They gave us R 8. They gave us R as how many there? 287. 85 what? 851 kilogram. Chief, they gave you down the question. When they pass this, what they give you. Alright, leave I know why I speak of this stuff. So we save ourselves time. Check the past question, this is what they give you in the past question. It's a passage I'm reading. Alright, so I have this stuff here. So what's there? I have T, I have T for both of them, so I can get this. It's the same gas. So this value is constant. My test is not going to get what there? Pressure. That's my test. But I already have PA and PB. Right? C is already constant. You can see T there. C is given for both of them. R is constant. But I'm to get P, I'm already given P. That's PA and PB. So what's this for this one again? Yeah. So here's the concept. For a fact that you're giving atmospheric pressure, that means I have this one here. That means this value you have here is what there? Not absolute. This value you have here is what there? Gauge. That's it. So my task now will get PA absolute and what there? PB absolute. That's it. So first things first, get PA absolute. PA absolute. The absolute pressure at point A, that's equal to P atmospheric plus P gauge, that's this one, yeah? Your normal PA is P gauge. So I have this. So this is now equal to, this value is 103, 1.03 is in var, plus PA is this, 2, also in var. If I add this up, it gives you 3.03 var. Do your conversion. It means that PA in its absolute form is equal to what's the value of var? Is it minus 5? It's 5, not minus 5. 5 Newton per meter squared. Alright. So I've gotten PA absolute. So this one now is now checked. So I can now get density of A. Alright. Do the same thing for B. Do same for B. Let me get PB absolute. PB absolute is equal to PB or P atmospheric plus this P gauge, PB. That's now equal to P atmospheric 1.03 bar plus PB 1.4 bar. Combined, this gives you 2.43 bar. So hence, PB atmospheric or PB absolute please is equal to, convert this, it becomes 2.43 times 10 to the power 5 Newton per meter squared. So converting bar to Pascal is this. Recall that mass density is equal to pressure all over RT. Reminds me, you have to convert T. Yes, you have to convert T. T is in degrees Celsius. So do your conversion. Add 273. What do I get here? 303 Kelvin. Yeah? Add 273. What do you get here? 293 Kelvin. Right. So therefore, for point A, I have that density at point A is mass density at point A is equal to PA. I'm working with the absolute value all over RA, or R of course constant, times T at A in Kelvin. So that's now equal to PA absolute. This 3.03 times 10 to the power 5 all over R. Where is it? Yeah, 287.851 times CA 293 in Kelvin. That means density at point A, mass density at point A is equal to what's your value? 3.59 kilogram per meter cube. Alright, so repeat the same thing for point B. So for point B, what have I got? Mass density at point B is equal to PB absolute all over R times T at B, and that's equal to PB absolute is 2.43 times 10 over 5, converting back, all over R reserve is 287.851 times TB. 303, I mean 303. So mass density at point B is equal to, what do I get? 9 kilogram per meter cube. So I have this one. So therefore, or from here, also record that we say R rho A UA AA is equal to rho B UB AB. Well, we said AA is equal to AB, so they cancel out. So I'm now left with rho A UA is equal to rho B UB. Find velocity at point B. So from here, get UB. UB would be equal to rho A UA all over rho B. So I have this. And that will be equal to rho A, that's 3.59 times UA. Does somebody recall UA please? 5? Like 5? Yeah. 5 all over rho B, 2.79. Alright. Okay, you're coming there now. You're coming there. From here, UB is equal to, please give me value. 6.43 units meters per second. Right, so I have this. Alright, so with this being done, what's next? Compare the discharge. Compare discharge at A and B. How do you compare discharge? And finally, does not know what next. So when you stop there, what do you come up with? Well, since you want to go far, let me take you further. Compare the discharge. You're now going to Reynolds number. Reynolds number is used to determine if it's laminar, turbulent, or in transition. So why are we going there, sir? Usually in science, listen, usually you're asked to compare two things. The concept is simple. So the idea is compare two things. It's as simple as which of them is greater, which of them is lesser. So just find the two values and say this one is greater than this one. That's all. That's how you compare. Or perhaps, listen. Or perhaps, listen, another way of comparing is by using math. Listen, if for instance, let's say both of them are mathematical alike, you can use, let me show what I mean. Let's say QA is equal to, let's say 2 discharge kilogram per second, discharge meter cube per second, that's volume of time. And let's say QB is equal to, let's say 8 meter cube per second. What relationship here? This one here is 4 times this, I mean. So in the line of comparison, you can say QB is equal to 4 QA. It still works like that. So this is how you compare. Two ways in comparing. Either express them with a mathematical relationship, or if there's no mathematical relationship, find the value and say this one is greater than this one, or this one is less than. That's how you do it. So the task is simple. Find this chart. So look up, please. Look up. In finding this chart at point A and point B, have I got all my parameters? Is something missing? Huh? Area is missing. Area is missing. They say compare the discharge. Let's get this charge. Record that this charge Q is equal to what there? Area times what? Velocity. And we know that since it's a constant pipe, the area is equal to AA is equal to AB. So just find area. What was diameter there again? Huh? 75 millimeters. Please convert. 75 times 10 to the power what there? Minus 3 meters. So therefore, area equal to pi b squared all over 4. That's equal to pi into d squared 75 times 10 to the power minus 3 all squared all over 4. So A is equal to value. Yeah? 4.42 times minus 3 meters squared area. So therefore this value for AA also AB. We said AA is equal to AB. Constant diameter is equal to A. That's this value. So therefore this charge at A, that's QA, is equal to AA, we said is A times U. So AA times what there? UA. That's equal to AA is same value, 4.42 times 10 to the power minus 3 into UA. UA 5. Alright, get this one. Alright, so from here, QA is equal to this value 0.0221 units. This charge, volume over time, meter cube per second. Also at point B, A or QB is equal to ABUB. This. And that's equal to AB is the same value, 4.42 times 10 to the power minus 3. Please recall UB. What do you have? No, UB. 6.43. Okay, multiply. What's QB? 0.028 units. Okay, 28 meter cube per second. Alright, so they say compare QA and QB. So what do you have there? Therefore, what's the comparison? It's obvious that QB is greater than QA. So therefore, QB is greater than QA. So this becomes your comparison. Likewise, you can say or QA is less than QB. Still a good comparison. So that's how you answer this question, please. How you work on this. That's